Time for our classification example. The two main types of supervised learning are regression and classification, and we are trying to show you the most concepts in terms of both regression and classification. We'll do the same here. Here's our example. There are two categories. One of them is cats and the other one is dogs. A good model explaining all the data looks like this: a quadratic function with a few errors. Following the logic we saw in our previous example, what would be an underfitted model? Well, of course, a linear model. Linear models are not very smart. Often, a simple linear model underfits if the data is not transformed. Around 60% of the observations would be classified correctly with an underfitted model. Now, an overfitted model would classify the observations perfectly, right? It has correctly identified all the cat and dog photos in the dataset. But once we give it a different dataset following the same quadratic function logic, it will perform poorly. Alright, let's conclude lesson with the following remark. What is a well-trained model then? Well, it is somewhere between an underfitting and an overfitting model. This fine balance is often called the bias-variance trade-off. Oh, and if you are a meme fan, there's this Facebook page, Machine Learning Memes for Convolutional Teens, that I follow. Some time ago, they posted a photo of a bed that beautifully exemplifies overfitting. It fits some people perfectly, but on average, missed the point of being a bed. Memes are an interesting way to check knowledge. If you find it funny, you most probably understand the concept. As you can see, we are back to our interesting conceptual lessons, so stick around and thanks for watching.